Hello, everyone. Welcome to our session for today. Before we start with our discussion, let us have the objective first for this lecture for today. So, at the end of the lesson, you should be able to define the basic quantities and fundamental concepts in mechanics. The second one, solve with two types of units. All right, so these are the objectives of our lesson for today. And then we have here the definition of mechanics. Mechanics is the science which describes and predicts the conditions of rest or motion of bodies under the action of forces. And we have here the categories of mechanics. Mechanics is categorized into three parts. One is the rigid bodies, wherein the statics and dynamics belongs to, and the deformable bodies, and the last one is the fluids. All right, then at a glance you will see here uh, quickly the three categories of mechanics: rigid bodies, deformable bodies, and fluids. Where this is where the incompressible and compressible uh, aspects are being discussed. But our focus in our course Mechanics 102 will be the rigid bodies, where we have here the static and dynamic. We'll study uh, this part here, bodies at rest. So it means statics, and also bodies in motion, that is dynamics. Okay? So in statics, both the resultant force and the resultant moment of force are zero. Alright, so remember that. In statics, both the resultant force and resultant moment of the force are zero, thus establishing the equation of equilibrium. So the keyword here is the word equilibrium. All right, so that is for statics. In dynamics, however, the resultant force and moment are not zero, and therefore cause a change in the state of motion of the body on which they act. So the body is in consideration is assumed to be rigid, and the resultant force couple system is applied at the center of gravity of the body. So dynamics includes kinematics, that is the study of geometry of motion. Kinematics is used to relate displacement, velocity, acceleration, and time without reference to the cause of motion. Right, so that is kinematics. So we'll be studying here the distance traveled by a particle or anything that moves with a corresponding velocity or acceleration. So that's about kinematics. Kinetics means the study of the relations existing between the forces acting on a body, the mass of the body, and the motion of the body. Kinetics is used to predict the motion caused by the given forces or to determine the forces required to produce a given action. All right, so you have to know the difference between these two uh, parts of dynamics. Then we have what we call particle. So when you speak of particle, so it does not uh, matter, no, what is the size of the particle, because in the context of this discussion, particle does not indicate the smallness of size. Rather, it means that the shape and size of the body do not significantly affect the solution of the problem under the consideration. So we might be talking about car moving or a man walking, so it doesn't matter. We consider them as particle. Then we have motion of a particle. Then we have what we call rectilinear motion. So the direction of resultant is constant. So the motion of a particle is along a straight path and is called rectilinear translation. And we also have what we call curvilinear motion. So the motion of a particle in this particular situation is along a curved line in two or three dimensions. So it's not a straight line anymore. It's a curved, okay, a curved line in 2 or 3 dimensions. And we will use here the system of units. We have what we call kinetic units that refers to the length, time, mass, and force. So 3 of the kinetic units referred to as basic units may be defined arbitrarily, and the fourth one, or the fourth unit, referred to as a derived unit and must have a definition compatible with Newton's second law. So what is that Newton's second law? So that is given in this formula. The vectorial force is equal to the mass times the acceleration, that is also in vector form. So force equal to mass times the acceleration. International system of units, or SI units. So we have here the basic units that are length, time, and mass, which are arbitrarily defined as the meter, M, second, denoted by S, and kilogram, denoted by kg. Force is derived unit, and again that is taken from this Newton's law. Force equal to mass times the acceleration, where our force must be expressed in terms of Newton. So 1 Newton is equivalent to 1 kilogram per, or 1 kilogram meter per second squared. Just the product of the this one, the mass, and this is the acceleration, 1 meter per second squared. So that is what we call Newton. Then we also have US customary units. So the basic units are length, time, and force, which are arbitrarily defined as foot, second, and pound. Mass is the derived unit. Again, that is derived from this Newton's law. Mass equal to F over A, force divided by acceleration. And usually the unit used here is what we call slug. So one slug is equal to 1 pound per foot per second squared. Okay, so the force here is expressed in terms of pounds. Okay, and then acceleration is in terms of feet per second squared. All right. Then systems of units. So these are the symbol and abbreviations of the systems of units that we are going to use in our discussions with mechanics. So we have here the parameter, we have here the conversion of units from British engineering system to international system, and the vice versa, international system to British engineering system. So we have here the length in terms of inches converted into meters, that is the SI. We have foot to meter, slug, and so on and so forth. And also the reverse, you're given the meter and you're here the conversion in terms of inches, meter in terms of foot or feet, kilograms in terms of slug. And then we have the mass, force, time. This is the example of mass. We have the example of force. So mass in terms of British engineering system to international system, we have the mass in slug to kilograms. And the reverse is we have the kilograms in terms of slug. Then for the force, we have 1 pound to Newton, and here Newton to pounds. Then time, seconds, so the same. Then specific or unit, so weight, we have here 1 pound per cubic foot equal to 157.1 Newton meter per meter cube, or the reverse, that is equivalent to this. Then we have the mass density, 1 slug per cubic foot, that is equivalent to 515.2 kilogram per meter cube, and this is the reverse. Specific gravity, same dimensionless value in both systems. Okay, then we have here the fundamental concepts. So we have time. So definition of an event requires specification of the time and position at which it occurred. Then mass, used to characterize and compare bodies. Example, response to Earth's gravitational attraction and resistance to changes in translational motion. Then another fundamental concepts, we have what we call force. So force represents the action of one body on another. So a force is characterized by its point of application, magnitude, and direction. That is, a force is a vector quantity. Then for space, associated with the notion of the position of a point P given in terms of three coordinates measured from a reference point or origin. So we have here the Newton's first law. So just to give you a bird's eye view of what is Newton's first law, second law, and third law. So the Newton's first law, it is if the resultant force on a particle is zero, so the particle will remain at rest or continue to move in a straight line. Alright, so this is the Newton's first law. The second law says that a particle will have an acceleration proportional to a non-zero resultant applied force. And the third law says that the force of action and reaction between two particles have the same magnitude and line of action with opposite sense. So these are the laws that we are going to tackle also as we go on our discussion in the coming topics. Then we have here the basic formulas. So we have the velocity denoted by this letter V. So this is the rate of change position with respect to time. And in our calculus, differential calculus, we have defined this as V equal to the derivative of the displacement. S is the displacement here with respect to time. So that is our definition for the velocity. Then we have what we call acceleration, denoted by small letter a. So that is the rate of change of velocity with respect to time. All right. But since the rate of change of the displacement with respect to time is equal to v, so therefore we have a equal to the derivative of v with respect to t, which is equivalent to the derivative of the displacement with respect to time with respect to time. So therefore, we have now the acceleration as our second derivative of the displacement with respect to time. Okay, so these are ones of the important formulas that we need to remember and understand because we will be using them when we solve problems. Now for uniform acceleration, we have the following formula. I will give you the formula and later on I will show you how this formula were being derived. So we have v, that is the velocity, equal to the initial velocity plus v0 here is the initial velocity plus acceleration times time. So usually this is called the final velocity. Final velocity is equal to the initial velocity. V0 here is the initial velocity plus at, acceleration times time. And for the displacement, we have this formula. Displacement is equal to, displacement means this is the distance traveled by a particle after a certain time period. So this is equivalent to the initial velocity times time plus 1/2 times a times t squared. And for the final velocity squared equal to VO squared or initial velocity squared plus 2 times a s. Alright, so these are the formulas that we can use in solving problems for uniform acceleration. Alright, so these are the definition of these formulas where v here is the velocity at any given time. Okay, so remember this definition of the symbols here, v, s, and t. So v, velocity at any given time, v0 or v sub 0 is the initial velocity, a is the acceleration time, t that is time elapsed, and s is the position. Position is the distance traveled or covered by a particle after it moves at a certain time. Okay, so we are going to use this formula class in solving the following problems. So there are around 8 problems here. I'll just give you quickly, and then I'll prepare another video to show you the solutions of these problems. So we have 8 problems here, as you can see, and just watch them in the next video that I'm going to upload. Thank you very much and see you in our next video. Bye.